Today we are going to learn about normalization and its types. Firstly, we will understand what is normalization. The process of organizing the data in the database to reduce data redundancy and improve data integrity is known as normalization. Data redundancy is nothing but having same piece of data stored in multiple places. And improving data integrity means ensuring the data is accurate and consistent. It is very important to remove data redundancy because it causes anomalies in the data. An anomaly in a database is an error occurred due to data redundancy. Performing normalizations on relations or table is to remove anomalies. As I said before, anomaly is nothing but an error. After performing normalization, the duplicates are removed in the relation. So normalization helps for faster querying. Let's dive into the types of normalization. And the types includes first normal form, second normal form, third normal form and a boys code normal form. Firstly, I want to explain about first normal form. If a relation is said to be in first normal form, if it contains atomic values. Here, atomic values means the smallest unit of data which cannot be further subdivided. And attributes of a table in first normal form cannot hold multiple values. It must hold only single valued attribute. The first normal form disallows the multi-valued attributes in a row, which means any row in the table should not have multi-valued attributes. Each row must be unique in first normal form. Here I am taking student table as example, which consists of name, roll number, branch and languages known as columns. In this table, languages known column have multiple values. So to achieve first normal form, we need to remove these multiple values in the languages known column, which means here Sai knows Telugu and English languages, but multiple values are not allowed in first normal form. So we need to create separate row for Telugu and English. Then I created another table by removing multiple values from previous table. Same process will be continued for Shiva and Raju. Now the table is in first normal form because the multi-valued attributes are removed in the table. Then I will dive into second normal form. A relation is said to be in second normal form. It must obey the rules of first normal form. Along with this, the relation or table does not contain any partial dependency. Partial dependency means the primary key column does not have duplicates. I will discuss this with a student table. In the student table, we have roll number, name, branch, and languages known column. A student is always identified by his or her roll number. So, roll number must be a primary key. But here we have duplicates in roll number column, which means there is a partial dependency in the table. So, to achieve second normal form, we must remove the partial dependency in the student table. Partial dependency is removed by dividing the table into two different tables. And here table 1 having roll number, name, branch columns and table 2 having roll number and languages known column. I have removed all the duplicates in the table 1. So thus the partial dependency is removed in the table. We can see that roll number column is a primary key column in table 1, which means the relation is said to be in second normal form. And the table 2 is a separate table for partial dependency. Now I will explain what is third normal form. A relation is said to be in third normal form if it is in second normal form and there should not be no transitive dependency for non-prime attributes in the relation or table. Transitive dependency means one non-primary key attribute depending on another non-primary key attribute. I am taking another student table as example having roll number, name, branch and fees columns. Here the table is in second normal form because there is no partial dependency and multi-valued attributes in the table, and the roll number column is the primary key column, whereas name, branch and fees are non-primary key columns in the student table. Here the fees of the student depends on which branch they are studying, which means the fees column depends on branch column. So there is a transitive dependency in this table. Now we need to remove this transitive dependency from the student table by diving by dividing the table into two tables. Table 1 consists of a roll number, name, and branch columns, where table 2 consists of a branch and fees columns. In table 1, roll number is a primary key column and name, branch are non-primary key columns, but they are not depending on each other because a Sai can be in CSE branch and also can be in AML or DS or ECE branches. So name and branch are not dependent on each other. So transitive dependency is removed in this table, and the table 2 is in separate table for transitive dependency. So the student table achieved third normal form. At last, I want to discuss about Boy's code normal form. Boy's code normal form was discovered and formalized by Raymond F. Boyce and Edgar F. Codd in the 1970s. The Boy's code normal form is an extension of third normal form and also popularly known as 3.5 NF. If a relation is said to be in Boy's code normal form, it must be in third normal form. And for any dependency, B depends on A must be super key. Using the student table, we will understand the Boy's code normal form. In this student table, student name is always identified by his or her roll number, and same as the branch name is identified by branch ID, which means the student name depends on roll number. So roll number must be a super key. A super key is nothing but a super key column does not contain duplicates. Same as branch name depends on branch ID, but branch ID is not a super key because there is a duplicate row in the both columns. So I divided the student table into two tables. Table 1 having roll number, student name columns. Table 2 having branch ID and branch name columns. Table 1 is already in BCNF because roll number is a super key column. Table 2 is also a super key after removing 121 CSC duplicates. So both the tables are in Boy's code normal form. Thank you.